All right, so in this video, we're just going to go over a couple of problems from worksheet number 5. And I'm just going to do a couple of randomly chosen problems to kind of give some of the ideas on this worksheet. And so let's just start with number 1, and we'll just choose a couple of them and then just try to get through some portion of each problem in this video. So theta equals 150 degrees. This problem says, with the help of the unit circle, sketch the graph of each angle theta in standard position. And okay, so we can go look at the unit circle, but we can also just do it without the unit circle. So we know that 0 degrees is here, 90 degrees is here, 180 degrees is pointing in the negative x direction. So 180 degrees would be too far if we're trying to graph 150 degrees. And so if we subtract 180 degrees, we take 180 minus 150, then this is 30 degrees. So if we draw a 30-degree angle, then this is our 150-degree angle. Okay, and if you go to the unit circle, you will see this as well. There's 150. I mean, it's easier to do it this way, I guess, but really you should be able to do it without the unit circle as well. So that rotation there, and then you can see that this is a 30-degree reference angle. All right, so nice. Then let's take a look at another one. Theta equals pi. So in radians, we should know that this is 0 radians. In the positive y direction is pi over 2 radians. Then in this direction is pi radians, 3 pi over 2 radians. And then if we go in a complete revolution, that's 2 pi radians. So this one is actually quite a bit easier, since this is, we're trying to graph theta equals pi radians. That's one of these quadrantal angles. And so that rotation is just going to be, starting in the positive x direction and rotating all the way to, 180 degrees or pi radians. So it's going to be a straight angle. And I kind of didn't even draw the initial side for part C that I did first. And so I'll draw that. Every angle has an initial side and a terminating side. The initial side we're going to always have at the positive x axis, in the positive x direction. Okay, so there's a couple examples there of problem number 1, just drawing some angles. Maybe I'll do one more. Let's take a look at one more. 7 pi over 3 for part G. That one looks nice. Oops. So 7 pi over 3. There's a couple ways that we could do this. Let's see. I'm going to start by converting this to degrees and then looking at it that way. So 7 pi over 3, we can multiply by 180 degrees over pi, and the pi's will cancel. 3 goes into 180 60 times, and then 7 times 60 is 420. So this is 420 degrees. So how do we graph 420? That would be, we start here at 0, 90 degrees, 180 degrees, 270 degrees, and then a complete rotation is 360 degrees. So 420, let's see, if we keep going, 90 degrees more would be 450 degrees. So that would be too many degrees. So our angle is going to be somewhere in quadrant 1 between 450 degrees and 360. So to figure out where it is in quadrant 1, we can subtract 420 degrees minus 360, and this gives us 60 degrees. And so a 60-degree angle would be somewhere around here. And so to graph the angle, it is actually, the initial side is the positive x-axis, as we mentioned earlier, but then you do one complete rotation and then 60 degrees more. Okay, so there is the rotation kind of signified by that circle and 60 degrees more. And so that is 420 degrees. I said that this reference angle here, we calculated over here to be 60 degrees. If you take a look at the unit circle, you'll see that this increment here means 30 degrees. This one means 45 degrees. And this one means 60 degrees. And so that's how I drew, that's why I drew it to that third tick mark. Let me scroll over to the unit circle. 30 degrees, 45 degrees, and 60 degrees is, what's indicated there. All right. So I'm just kind of speeding through these. I have my office hours in a little bit. So, I'll just try to get a few done. Problem number 2, SOHCAHTOA. We talked about this in every one of my classes, so I won't really talk too much about this, but the secant of theta, if you're given a triangle, the secant of theta is the reciprocal of cosine. So since cosine is equal to adjacent over hypotenuse, then the secant is hypotenuse over adjacent. And so if we're looking at this angle here, the hypotenuse is the one up here. The adjacent is the one down here. The third remaining side is this side here called the opposite. Okay. So hypotenuse over adjacent. And then if we use the letters that they gave there, that would be D over F. And you can fill in the rest of that table. Yeah. Right, very nice. Problem number 3. With this one here, we want to find the cosine. Let's do 3B. We want to find the cosine, cotangent, cosecant. And you have to know that the cosine of theta, according to SOHCAHTOA, is adjacent over hypotenuse. If we label the adjacent side, the hypotenuse, and the opposite side, then we want to find this unknown side length and then divide it by 5. Okay, so our answer is going to be something over 5. To find that unknown side length, we can just use the Pythagorean theorem, which says that the leg squared plus the other leg squared equals the hypotenuse squared. And so a squared plus 9 equals 25. If we subtract 9 on both sides, then a squared equals 16, or a equals, if we take the square root, we get plus or minus 4. But in this case, since we're talking about a represents the length of a side of a triangle, and so that length will be positive 4. So this is 4 over 5. And then you can fill in the rest of those using the definition of cosecant as given, in problem number 2, and cotangent. All right, so that's problem number 3. Uh-oh. There we go. All right. So problem number 4. Given an angle in standard position, find the coordinates of the associated point on the unit circle in exact form. So this one here just comes down to finding this angle on the unit circle. 11 pi over 4. We can try to look for it on the unit circle. 11 pi over 4, is that anywhere on here? I don't see it. So remember that the unit circle only goes from 0 degrees to 360 degrees, or 0 radians to 2 pi radians. If we take a look at 11 pi over 4, 11 over 4, if we divide 11 by 4, 11 goes into 4, 4 goes into 11 2 times. 2 times 4 is 8, and then there's a remainder of 3. And so 11 pi over 4 is really 2 2 3/4 pi, or 2 pi plus 3 pi over 4. So there is a whole rotation of 2 pi that we can eliminate, because that would just give us a coterminal angle. And so we can really just look at the angle 3 pi over 4 and find the associated point for that angle, and that would be the same as for 11 pi over 4. Let me demonstrate that here on the unit circle. So 3 pi over 4 is this angle here. So here is 3 pi over 4, and then here is 11 pi over 4. So it's just one extra 2 pi rotation around, and then it terminates in the same spot. So for both of these, the associated point is negative square root 2 over 2, comma, square root 2 over 2. And my iPad is freezing up here for some reason. Okay, let's see. So. All right, so we said the associated point was negative root 2 over 2, comma, root 2 over 2. This is the answer for part E. Another way that we could have done this, if you wanted to convert 11 pi over 4 to degrees, maybe you're more comfortable with degrees. We can multiply 180 degrees over pi radians. The pi's will cancel. 4 goes into 180. Excuse me. 4 goes into 180, or I can reduce them both by 2 to get 2 and 90. And then 2 goes into 2 and 90, 1 time and 45 times. And so if I multiply 11 by 45, that gives me 495 degrees. And from there, you can also see, well, 495 is kind of a big number. It's bigger than 360 degrees. So you can see, hey, that is not on the unit circle because it's too large. So if we take 495 and subtract 360 degrees, then we get 5, 3, 1. We get 135 degrees. And so the associated point for 135 degrees will be the same as the associated point for 495. And you can see, well, that's exactly the angle that we were looking at just a moment ago in radians. Okay, so if you want to do it in degrees, you can do it that way as well. All right. Let's see. Problem number 5. It says find the exact value of each trig function for the given angle and use the unit circle. So let's pick one that's maybe a little large here. Negative 300 degrees. So negative 300 degrees, there's a couple ways. With these, there's so many ways to do these problems. Oops. So let's do it maybe 2 ways. And so if you understand the first way, you don't want to see the second way, just forward through this. Negative 360 degrees, negative rotation. So we'll go in the clockwise direction. And so here's 180 degrees so far, negative 180. We want negative 300. So we would go, here is negative 270. And we want negative 300. So we should go 30 degrees more, which would put us right here. This is negative 300 degrees. And so the associated point is 1/2, comma, square root of 3 over 2. This is the x coordinate and the y coordinate. And I believe we were asked for the tangent of negative 300 degrees. So tangent is equal to y over x. And so we would just take the y coordinate and divide it by the x coordinate. And that would be square root 3 over 2 times 2 over 1. The 2's cancel, and we get the square root of 3. over 1 if you want. So that is our answer. So I just found negative 300 degrees. I found the X and Y coordinates associated with that angle on the unit circle. And use those X and Y coordinates to find the tangent of that angle. What's another way that we could have done this? Because, 300 degrees is not on the unit circle, negative 300, excuse me. So we could have done this. Oh man, there's so many ways. I'm thinking of more ways to do it as I'm thinking about this. The other way would be to find a coterminal angle that is on the unit circle. So within 0 to 360 degrees. And so what we would do is we would take negative 300 degrees. Since it's too small, it's too low because it's less than 0. We can then add a full rotation to that, 360 degrees. And you can see that this would be 60 degrees. So that tells us that the tangent of negative 300 degrees is the same as the tangent of 60 degrees. And so we just go to 60 degrees on the unit circle, and it's the exact same point. And so you find the tangent by doing y over x, and the work would be exactly the same. Okay, so an alternate way if you'd like to see another way of doing this. And so I'll leave it there for that one. And then I have my office hours in just a couple minutes, so I'll end pretty soon. Yeah, let's take a look at one more of these on problem number 5. And let's take a look at E. That one's a nice one. Secant of 29 pi over 6. So we can divide 6 into 29 to see 29 pi over 6. Well, we know 6 goes into 29 more than 2 times. So this angle is going to be, let's see here, if we divide 6 into 29, 6 goes into 29 4 times. 4 times 6 is 24. And if we subtract, we get a remainder of 5. So 29 over 6 is the same as 4 and 5/9. So 29 pi over 6 is the same as 4 and 5/9 pi. 5/6, excuse me. 5/6 pi. And so that's the same as 4 pi plus 5/6 pi. And the reason I'm writing it this way is because here we can see this is 2 pi plus 2 pi at 4 pi. So we, in a sense, we can ignore that and find a coterminal angle with 29 pi over 6. So let me write 5 pi over 6 is coterminal with 29 pi over 6. And so this means that the secant of 5 pi over 6 is the same as the secant of 29 pi over 6. And so all we need to do is find the secant of 5 pi over 6, and we'll have our answer. The secant of 5 pi over 6, the secant of any angle, I'll go left now here, is equal to, what is it? This is the reciprocal of cosine, so it would be hypotenuse over adjacent, or in terms of x, y, and r, that would be r over x. And so let's go find 5 pi over 6, this angle on the unit circle. So this is the associated point. Negative square root 3 over 2, comma 1/2. I'll write it here, negative square root 3 over 2, comma 1/2. And so we're going to do r over x. In this case, we are talking about the unit circle. And so the value of r, well, the value of x and y are given. the value of r is also given because we're getting this point from the unit circle. R has a value of 1. And so we can just plug in. R is 1. X is negative root 3 over 2. The way that we divide by a fraction is to take the first value and multiply by the reciprocal of the second fraction. And so this comes out to negative 2 over the square root of 3, or negative 2 root 3 over 3. That is our answer there. All right. And since I have my office hours right now, I will stop this video and then I'll make another video covering some of the parts of the remainder of these problems. All right, don't forget to, leave a like on the video to tell me that you like it, and we'll see you in the next one.